Alright, here we have another example of a rational inequality, and this one's getting to be just a little bit more involved. So here we have 3x plus 5 times x plus 8 divided by x minus 2 less than or equal to 0. Well, we have a single rational expression compared to 0, so our first condition is met. The numerator and the denominator are both fully factored, so that condition is met. And let's make a note about the brackets and the parentheses. Because we have a less than or equal to, that's telling us that we're going to be using brackets for our endpoints. Now, with the exception of where the denominator would be 0. If we were to put a 2 in here for x, 2 minus 2 would cause a 0 denominator. So that tells us that we cannot use 2 as a valid x. So if we have to use 2 for some reason, that's telling us that we're going to have to use a parenthesis on 2 instead of a bracket like we normally would. Alright, let's get started. We're going to take each one of our factors, the 3x plus 5, set it equal to 0, the x plus 8, set it equal to 0, and the x minus 2, and set it equal to 0. So whenever I solve each one of these, this would be 3x equals negative 5/3. Sorry about that. This would be 3x equals negative 5, and then dividing both sides by 3, we would get negative 5/3. I got a little bit ahead of myself there. And then to solve the second one, x would equal negative 8. And to solve the third one, x would equal 2. So these are our critical values. When we set up our number line, we're going to be using those numbers to help us segment up or separate out the number line. So let's put the negative 8 over here, and negative 5/3 would be somewhere around here, and then we'll put our 2 here. Now I realize those are not spaced correctly, but it doesn't really matter. We're just looking at what's going on around them. So as long as they're in the right order, that's all that really matters here. So I'm going to separate out my number line, and then I'm going to write each one of those factors. We had a factor of 3x plus 5, x plus 8, and our denominator was x minus 2. So let's look at some numbers here. Let's pick something to the left of negative 8, like say maybe negative 9. Negative 9 minus 2 would be a negative number. Negative 9 plus 8 would be a negative number. And 3 times negative 9 would be negative 27, plus 5 would be a negative number. Now, when I multiply two negative numbers, because that's what's going on here in the original problem, multiply two negatives, it becomes a positive. Divided by a negative would be a negative answer. Let's do the same thing for over here. Let's choose something in between negative 8 and negative 5/3, like maybe negative 5. Negative 5 minus 2 would be negative. Negative 5 plus 8 would be positive. And negative 5 times 3 would be negative 15, plus 5 would be a negative number. Now a negative times a positive would be negative, divided by negative would be a positive number. Now we'll choose something in here like 0. 0 minus 2 would be negative, 0 plus 8 would be positive, and 3 times 0 plus 5 would be positive. So positive times positive would be positive, divided by negative would be negative. Lastly over here, like say 5. 5 minus 2 would be positive, 5 plus 8 would be positive, and 3 times 5 plus 5 would be positive. So positive times positive divided by positive would be positive. We're looking for where they are negative, so I want these sections right here. That would be negative infinity to negative 8, joined with negative 5/3 to 2.